Chris Goodson and I did our presentation on implementing 3D design learning with or without a printer, and we titled our presentation 3D Printer Optional because we really focused on how the 3D printer is not something that the students have to have, whether we focused on the design process that needs to be at the center in these classrooms. So we start with our guiding question, why should we do 3D printing? And we started with some examples. For example, the problem-based learning and using 3D printers to make our projects. We talked about this classroom model where students are making their own models of DNA, and you can see the two different types. And we went into further detail about the design process these students went through. We talked about teacher manipulatives, and then we talked about how 3D printing can go all the way down into the K2 level. For example, in this example, the students made a life cycle of a butterfly, and this really cute one with the life cycle of a chicken.
So I want to talk for a minute about iterative design, or the design thinking process. The idea behind this is giving your students a chance to fail in a safe place. And how does that have anything to do with design? Well, a lot of times our students think of assignments and designs and things that they make and problems they solve as being a one-time thing. In other words, you are given a problem, you try to solve the problem, and either you fail and you're a bad student, or you pass and you're a good student. And in the real world, that's not the way it works. In the real world, we follow a process like this. This process really came from software design. You empathize. In other words, you try to figure out what your audience wants. Then you define what they want, what the product's going to be to satisfy that want. And then you move on from there. And you make a prototype, and you test the prototype, and then you go back and you change the prototype, and you test the prototype, and you change the prototype, and you test the prototype, and you keep doing that. And really, the process becomes more like a wheel, where you refine, prototype, test, note strengths and weaknesses, refine, prototype, test, and this goes on in a spiral, and the spiral gets tighter every time until you have a final product. It's still not perfect. Nothing's ever perfect, but it's as good as it's going to get for you now to be able to release it. Now, this is the thinking we want our students to think about, because they know how to do this. They just don't always do it in school. For example, skateboarding. This would be the picture we would think of in skateboarding, flying majestically through the air. But the kids who skateboard will tell you that for every one instance of this happening, they get about 1,000 instances of something like this happening. But it's okay. Failure in this context for them is acceptable because it's part of the process of eventually getting to be able to do that. So iterative design basically works the same way. I want to give you some basics to start with of how 3D printing works. And this is going to be the easy version, so it's okay. First of all, you start out with a three-dimensional object that's been designed in the computer. But we need to understand what that means. This is not a solid object. This is a mathematical representation. This is a series of numbers, of angles, and little shapes and things like that. So it's not real. You couldn't turn this into a real object without some intervention. So we go from that 3D object, we put it through some software, and that software gives us a new file. And then what we want to do is we want to take a roll of plastic filament and turn it into that object. So this roll of filament goes into your 3D printer. There's a gear that grabs it and drags it and feeds it into this part. This part gets very hot and it melts the plastic. You'll notice that it squeezes the plastic down to a smaller diameter and squirts it out like a can of Cheez Whiz. Okay, so you have three motors on your printer that can move the print head in three dimensions, X, Y, and Z. What you did is you took that 3D object and you converted it into instructions that your particular printer can understand in X, Y, Z. So it moves the print head around, squeezes out that hot plastic, and it solidifies as soon as it hits the bed. And so what that means is that it builds it up one layer at a time. So it builds one layer, moves up a little bit, builds the next layer, moves up a little bit until you've completed the object. And it ends up looking a lot like this when you print it. Since that plastic solidifies as soon as it comes out, it lets it build up on top until you're done and you have a 3D object.
So all of that is great, but how do we design a 3D computer model? We decided to showcase these three tools in our session, Tinkercad, 3D Slash, and Leopoly. We asked the audience to raise their hand if they had used Tinkercad, thinking that majority of the audience would have heard of this tool, but we were surprised that not many have heard of it or used it. So we spent a little bit of time showing some tips and tricks with Tinkercad, but we also showcased 3D Slash and Leopoly. 3D Slash is great for those students who are used to Minecraft because they can either take a box and destroy it, or they can build up from boxes. And we talked about Leopoly as being something more like a sphere that you can then etch away at. And so we showcased these 3 tools and we gave them a design challenge. We asked them to design a spin top and submit the design to us so that it could be printed. We gave them time to do that, but then at the end we reminded them that design comes before printing and that 3D printers really are optional. We asked if there were any questions, and we ended our session by sharing our contact information.